Recording in progress.
Hang on one second. Hi, good morning, good afternoon, good evening, wherever you're joining us from. It is top of the hour and, let's see. Yes, top of the hour, and we are ready to get started here this morning. I cannot see how many are coming in or not, so I don't know if more are coming, but I do know we have a pretty full agenda for this morning. So we're going to go ahead and get started. Thanks for joining us this morning. If this is your first time to join us, my name is Stacy Sire and I'm the current president. I want to welcome you and thank you for being here. Be sure and jump into the chat or the chat box and let us know who's here today and where you're joining us from. We were just chatting behind the scenes here that there was someone from Poland last month and India, I think a couple of months ago. So we appreciate and understand the time difference and appreciate you being here. So a couple of announcements before we start our program. Just know, if you haven't noticed already, our website is under construction. So be on the lookout for our new look and feel when it is unveiled soon. We think that you're going to find it easy to navigate and full of really good, useful information. And as the board is looking at our programming and services that we offer you as our members, we know there's a collective pool of talent in our chapter, and we want to be open and welcome new ideas, thoughts, inspiration. So to this end, on the website, when it's unveiled, feel free to submit some ideas, thoughts, things that you think can help make our membership even better. We all want to become better professionals, and this is one way we can do it. So, okay, let's get started. Now, if you have any questions or comments during our webinar, as typical, be sure and pop it into the question and answer or the chat, and we will get, if Hunter, who's already said he's pretty good at looking at the comments, if he doesn't catch them, we will catch them for you. So today I want to introduce Hunter Morrison, who is the technical director at AWI. Hunter works with architects, specifiers, and project teams all over to provide technical guidance and help turn our design intent, stress on the intent, into truly buildable designs for commercial architectural woodworking industry. And I know a lot of us actually perk up when we hear that there are measurable lab tests to validate our designs. So Hunter, you definitely have our attention today. We're excited to learn more about this and so much more about AWI. So Hunter, the floor is yours.
Hello, everyone. Thank you, Stacy, for that introduction. As you said, yes, I am Hunter Morrison. I'm the technical director for AWI. I'm going to kind of assume everyone is going to be somewhat familiar with AWI, but just in case you're not, we are an industry trade association. We represent the commercial architectural woodworking industry, and our membership is made up of manufacturing companies, architects and designers, students, and some industry suppliers as well. One of the primary roles of AWI is writing standards for that commercial architectural woodwork industry. In today's presentation, I'm going to focus on one small portion of our standards, but we'll kind of quickly go over at the beginning what our full scope of standards is. And then, as Stacy said, if you have questions along the way, don't hesitate to drop them in the chat. I do my best to monitor it. But if I miss anything, please feel free to kind of interrupt me, Stacy, and I will do my best to answer those as we go.
Will do.
And then starting out, this presentation is available for AIA continuing education units. So I don't know if you keep a spreadsheet of those who attend and their AIA numbers, but if you would like a credit, then I'll get those from you after, and we can coordinate with our education team to get those units sent back out. So getting started here, and I see a couple people coming in from Krakow, Poland, Oregon, Ohio, Texas. So far I can go, we have AWI members in every single location that I'm seeing pop up in the chat, which is kind of neat to see the lineup with the CSI chapter. So this first slide, AWI, a registered provider with AIA continuing education units. So like I said, if you have your numbers and contact information, Stacy, I can work with you after the fact to get that list. This course specifically is about ANSI AWI 0641 Architectural Wood Casework. Learning objectives going to be to identify some differences between the previous edition of standards compared to this current edition that is out on the market. Educate on some of the differences between aesthetic-based standards and performance-based standards. Become familiar with the impact of ANSI and performance-based testing as they relate specifically to wood casework. And then learn how the specifier can benefit from using this specific standard and AWI as a suite of standards as well to impact the outcome of a project. So to kind of get things started, the whole thing comes up of why are standards important? And we'll kind of start out with a fun infographic here of, I'm sure you have had projects where you have visualized a certain design in your mind. You try to communicate it to a customer, to a manufacturer, to a general contractor. And along the way, everyone involved in that project is going to interpret the design intent a little bit differently. So what you might explain it is as a three-tiered swing. How a project leader is going to understand it is a one-tiered swing, but it kind of cuts in half of the tree here. There's how the business consultant describes it, which is a comfortable chair hanging from a tree. What gets installed, what the customer was billed for, how it's supported, but what the customer really wanted and needed at the end of the day was a simple tire swing. Standards are important because they help everyone to speak the same language. It gives one document that is consistent between all the parties involved. Everyone is going to be reading the same thing to determine what it is they need to build. And there's none of this telephone game communication between all the different parties involved in a project. So standards are important because they help everyone, quote, speak the same language. AWI has a long history of standards development, starting in 1961. I don't necessarily need you to drop it in the chat, but just kind of make a mental note of where you maybe became familiar with AWI as a standards organization and what document you had originally started using in your projects. So starting in 1961, we had the quality standards for architectural woodwork. And then kind of on a rolling 5-year basis, made updates, the quality standards illustrated, architectural woodwork quality standards, moving forward into the 90s, architectural quality standards. This might be the first one that many people are going to be familiar with. 1999 edition, the QSI 7th edition, QSI 8th edition. This is the first one that I would have become familiar with. This is the 2009 Architectural Woodwork Standards Edition 1. 2014 edition 2, this kind of became known as the Manual for Architectural Millwork or the Woodworking Bible. It contained all sorts of information from standards and education content. And then that's kind of where we ended up. I see some people saying kind of in the late 90s, 1997, kind of becoming familiar with AWI. So at that time, not to age myself, but 1997, I would have been 7 years old. So I don't even think a career in woodworking was on the horizon for me.
Ouch. Ouch. Thanks, Hunter.
Yeah. But it's interesting to see where everyone becomes familiar with it because, like I said, standards are updated every kind of 5 to 7 years just to make someone has socks older than me. But to make sure that we're staying up to date with changes in the industry and what expectations are on a woodworking project. In the kind of 20 teens, 2015, 2016, AWI said, hey, we want to go a different route for standards development. The past 50 years have been a group sitting in a room, writing standards and determining what is best for the industry with little to no outside feedback from our stakeholders. So we chose to develop standards going down the ANSI process. I'm sure many of you are familiar with, quote, ANSI standards, but maybe you aren't familiar with what they are. ANSI is also an association that monitors and protects the standards development process, and they require that all standards that become ANSI accredited be developed with consensus, balance, openness, and due process. And that is kind of the high view level of what an ANSI standard is. ANSI are not experts in woodworking. They are not experts in electrical items. They are not experts in concrete, but I'm sure you can find ANSI standards related to all of those topics. ANSI simply means that those standards were developed with consensus, meaning the public is allowed to vote on whether that document should or should not be a standard. Balance, which means we have a balance of stakeholders. Typically, those are going to be producers or manufacturers. They're going to be general interest, which kind of falls into the education categories, and they're going to be users. So in the case of woodwork standards, the users are typically going to be architects and designers. Due process is just that. We have a process in place for standards development that we follow, and ANSI has approved our process. So with that, we have been developing standards since 2015 following the ANSI process, and to date, we have a pretty large suite of standards covering project submittals, care and storage, materials, factory finishing, finished carpentry and installation, architectural wood casework, wood stair handrail and guard systems, manufactured wood casework, and countertops. We have a few additional standards that are not covered on this slide that relate to millwork and wood trim, wood frames, and specialty casework as well. But today, and I kind of moved through these initial slides somewhat quickly because I want to get to the meat of this presentation, which focuses around 0641 architectural wood casework. Architectural wood casework, specifically on the commercial side of the industry, can be anything like this, which would be a typical break room or kind of back of house storage space, which is going to be plastic laminate cabinets, and it can range as far as something a little more ornate, which would be wood veneer casework with stile and rail doors. The countertops can be stone, plastic laminate, wood veneer, solid wood, anything like that. So AWI standards really cover the full spectrum of what you would expect to see on any given project, whether it's back of house melamine and plastic laminate cabinets, or whether it is kind of the main attraction front of house wood veneer cabinets with stile and rail doors. For those of you who would be familiar with previous editions of AWI standards, you might be kind of familiar with the way those were set up, which would be section 10 for casework. It would be section 10, then it's going to give you a reference of section 10.4.7. Then as you get to specific line items in the standard, it's going to be section 10.4.7.3.2.1. And that structure could kind of tier all the way down until you get to a specific line item. We've kind of reduced that numbering system for these new standards. It's broken up into 5 main categories: 1, purpose; 2, scope; 3, requirements, which has several subcategories; 4 is going to be a figures and illustrations section; and 5, which is not shown on the screen here, is a supplemental section. Within requirements, we have subcategories of general, material requirements, structural requirements, and then of course all the aesthetic requirements that you're going to be familiar with. And that's kind of where the numbering really stops for these new standards. We have, for example, 3.1.1 measurements would be a requirement, a general requirement, and then a general requirement about measurements. And then beneath those sections, it's simply A, B, C, and D. So instead of that previous 10, 4, 7, 1, 5, 9er that you could have going off in there, what you have is 3.1.1 measurements, line A, 3.1.1 measurements, line B, and so on. It makes it a little bit easier to navigate the standard because you don't have all these various subsections and subsections that you're trying to kind of organize and navigate through. So we call it a standards suite now because all of the standards on that previous slide, from submittals all the way through wood trim, all work in harmony together. They're meant to kind of supplement each other, but they are also completely separate documents. All of our standards are used unless otherwise specified. So contract and specifications will always supersede AWI standards, meaning if the standard is included in the contract, but a contradictory requirement is also in the contract, the contract requirement would supersede anything that the standard says. An example might be AWI standards require a gap tolerance of 1/8 of an inch. If the project contract says all gap tolerances are to be 1/16 of an inch because we want it to be a little bit tighter, that project contract requirement would supersede the requirement in the standards. But with that in mind, AWI standards do have some defaults set in place. So you could simply specify AWI standards, not have to worry about, do we need to tweak or modify the requirements? We just want to specify the standard and get a default. Those defaults are going to be a structural performance, which is duty level 3, which we will cover in more detail here in the coming slides, and an aesthetic default grade of custom, which again, we'll cover in a little bit more detail as to what that means in coming slides. AWI also uses metric dimensions. Previously, we listed the imperial dimension first, metric dimension second. We flip-flop those. Now the metric dimension is first and the imperial dimension is second. It doesn't really impact the use of the standard so much, but it is something that stands out as a difference as people start going through. They're seeing metric and wondering why that's the case. The simple answer is ANSI as an association requires us to have a policy for metric dimensions, and this is the metric policy that we've settled on. So I kind of mentioned structural versus aesthetic for the casework standard. Structural is divided out into performance duty levels, which are new for AWI standards in that if you were to open up the AWS second edition or any previous standard, you will not see performance duty levels. And then aesthetic, premium, custom, and economy grade, if you open up any standard from AWI back to at least the 90s, you will see some form of premium, custom, and economy grade. So aesthetic grades are very similar. Structural performance duty levels are new. Structural performance duty levels do not apply to every AWI standard in our suite today. They apply to the casework standards. Performance duty level, there are 4 of them. The typical application is going to be light commercial, commercial, institution, and laboratory. Another way to look at it, and in my mind, a better way to look at it, is duty level 1 is the lowest structural performance requirement. Duty level 4 is going to be the highest or most stringent structural performance requirement. And we'll get in a little bit more as to what the specifics of that mean. And then as far as aesthetic grades go, premium grade is the highest quality of control over materials and workmanship. Economy grade is going to be the lowest level of quality control over materials and workmanship. Custom grade is a nice, happy middle ground. One way to look at that and consider that is back of house cabinets in a storage room would more likely be economy grade. Front of house cabinets that are wood veneer, they need to be the highest level of materials, quality, and workmanship are going to be premium grade. Custom grade can cover kind of anything in between. Custom grade is going to be the most common grade that gets specified in many cases. Premium grade is going to be the second most common. And in my experience at AWI, economy grade is kind of rarely, if ever, used. There are instances where I personally would recommend economy grade because it can save in terms of dollars on a project and in terms of cost. It can save money because of just the quality of materials is going to be that lowest grade, which means they are going to be less expensive. But the places where you would use economy are going to be a little bit more restricted in many cases to those back of house, storage room type use cases. Materials and manufacturing. So as I mentioned, the standard does cover certain requirements for materials and manufacturing. There are instances in the standard where instead of using solid wood, the standard recommends or requires something like particle board, MDF, or veneer core plywood. It's kind of long been considered that solid wood is a superior product. That is not always the case in terms of architectural commercial woodworking. There are cases where particle board, MDF, and veneer core, you get a smoother surface, you get a flatter surface, much less prone to warping, expansion, and contraction, and it can be less prone to telegraphing if there is a surface material placed on top of it. Question that I just saw pop up, can you have economy grade industrial performance cabinets? I'm going to go back a slide real quick and just kind of highlight that. These two requirements are independent of each other. You can mix and match in any way that you would want. So you could have an economy grade duty level 1 cabinet or an economy grade duty level 4 cabinet. You could have a premium grade duty level 1 or a premium grade duty level 4 or any combination thereof across the matrix that these two would create. Materials and manufacturing lend themselves to, in the terms of casework, how a cabinet gets built. The materials a cabinet is built out of, you're going to have the cabinet body, which is going to include the top, bottom, back, left side, right side, and an adjustable shelf. And then you're going to have the door and drawer fronts. The materials used, depending on the design of the cabinet, the overall aesthetic look can be different. Drawer fronts in some cases might be solid wood. The doors in some cases might use solid wood stiles and rails. And in other cabinets, depending on the need and the use, might use MDF or particle board core fronts with plastic laminate or wood veneer on them. So I've kind of talked a lot about structural and these performance duty levels, but the question always comes up of what does that mean and why is it important? So we started with a methodology. Our previous methodology in standards for the structural requirements for casework was to provide a kind of laundry list of options that a manufacturer could choose from. And as long as they built their cabinets meeting that laundry list of items, then their cabinet would be considered conforming from a structural performance standpoint. What that list of options looked like was if a cabinet uses doweled joinery, for example, the first dowel had to be placed within 1 inch of the front edge of the cabinet, and then no more than 96 millimeters apart, moving backwards for every dowel placed subsequently. If another type of joinery was used, it had to fall within the list of options that was available. So a cabinet could use some form of conformat screw. A conformat is a kind of thick metal wood screw that resembles a dowel, but it has very coarse threads on it. And there were requirements about how far those could be placed apart. If a cabinet used a doweled, or a dadoed joint, for example, there were requirements around what the dado joint could be and how it was built. There were requirements around the thickness of materials used. For the back panel, there were requirements around how many and how far apart staples could be placed and where they needed to be placed around the perimeter of the back panel. So our previous methodology was to provide a list of options to the manufacturer and let them pick and choose to create a cabinet that was assembled and built. But there was really no indicator on whether that cabinet would actually perform over its lifetime and whether that cabinet would stay together under certain loads that might be placed on it in the field. So we developed a test methodology that could apply to any manufacturer, whether they're building on a large production line like this, whether they have a slightly different manufacturing setup, but kind of giving them freedom and flexibility to manufacture in a way that best suits them, regardless of whether they're using dowels, conformats, dados, staples, certain types of glue, or certain thicknesses of material. So instead of saying, here's your laundry list, we said, here is a performance metric that you have to meet. So a manufacturer today can build a cabinet any way that best suits their manufacturing processes within their manufacturing plant. What that cabinet has to do is meet a series of tests where a load is placed on the cabinet for 24 hours. After 24 hours, that load is removed from the cabinet and we examine for points of failure. That would be cracking in materials or complete joinery failure. The top row is one set of cabinets that we test. The bottom row is a second series of base cabinets. What you can see in that top row are before, during, and after pictures. Bottom row is also before, during, and after, but I see that two are out of order. The bottom middle and bottom right are flip-flopped. But what we do is we install a cabinet as if it were to be installed in the field in a testing lab. We load a series of weight onto the top of the cabinet. On that top row of pictures, the example is there's 500 pounds within that gray basket. There's 50 pounds within each drawer box. So each drawer is opened, 50 pounds is placed inside it, and then the drawer is closed. The adjustable shelf there has probably about 250 pounds sitting on it, and then each door has 100 pounds on it. We leave those loads in place for 24 hours. We take it off and we examine the cabinet. We do this same test for base cabinets, wall cabinets, and tall cabinets. Every cabinet that we test is a standardized size and layout because we're trying to determine whether the materials used and the method of joinery used meet those requirements. So we have to standardize our test in some way, and that is what we have done. A cabinet that has been tested as a two-door, two-drawer, and passed at the specific duty level can then be modified to be a drawer stack, a two-door base cabinet. It could be a single-door, single-drawer base cabinet. It could be a two-door, one-drawer base cabinet, as long as the materials used in testing and the joinery method used in testing remain the same. The wall cabinet looks like this, where we load weight onto the top, adjustable shelf, and bottom, and the doors, and a supplementary test where weight is only loaded onto the bottom. And the test for tall cabinets, again, we load weight onto every adjustable shelf and the fixed shelf, and a supplemental test where additional weight is loaded only onto the fixed shelf. And again, these are all used to determine whether the cabinet materials and the joinery meet the requirements of our standard. These tests for cabinets only are considered pass-fail. So if we unload all the weight at the end of this and there's no cracking of the material, no unrepairable joinery separation, or complete failure of any specific joint or material, then the cabinet passes at the duty level it was tested to. On the other hand, if a cabinet fails, it's going to look something like this. It's probably going to be a pretty obvious failure where you have the fixed shelf, the adjustable shelf, or the bottom of the cabinet simply failing under load. What that can tell the manufacturer is their dowel spacing that they used. Maybe they said the previous standard was 96 millimeters on center. We want to expand the spacing between our dowels, so we're using fewer dowels. So they put a much larger space between their dowels. Now that means they have less dowels holding the components in place, and that causes the cabinet to fail. So what that gets you as the architects and designers at the end of this and the specifiers is, as long as the cabinet has passed the test, as what is shown in some of these photos compared to these, you have to be less concerned about the manner in which the manufacturer built them, because they are doing what best fits the needs of their process, but it ensures that you're still getting a cabinet that is not likely to fail under any realistic loads in the field. So I say realistic versus laboratory loads. And what does that mean? I'm going to go back one slide as the example. The tall cabinet bottom row in the middle, so that photo on the bottom middle has 1,100 pounds loaded onto that fixed shelf. Never would I ever recommend or say that a cabinet in the field should or could hold 1,100 pounds on the fixed shelf. One, it's a huge safety thing of you don't want people in, around, or opening and closing a cabinet that has 1,100 pounds sitting on a single fixed shelf. So that might cause you to ask the question of, why are you using 1,100 pounds in your testing if you would never recommend or allow that to happen? And the answer is, we are trying to test the limits of the cabinet construction within a 24-hour period. We need to load it to its limit to understand whether or not it will or will not fail to determine whether that cabinet has a structural performance that can be kind of correlated to its field performance. So that goes back to the duty level 1 of the weight load used to test duty level 1 is much lower than the weight load to test duty levels 3 and 4. To give you an example, the photos on the screen were all duty level 3 cabinets. So each shelf in that top middle row has about 300 pounds. The one in the bottom middle, as I said, has about 1,100 pounds. We determine the weight loads based off the square footage of the cabinet. So there can be some variance of about 5 pounds between cabinets if one fixed shelf is slightly less deep than another fixed shelf. So that's how we're determining those weight loads. And that's why we are using the weight loads that we are in testing. So I've talked a lot about cabinets. We also do testing on drawer boxes and shelf suspension system. Drawers we have broken out into 2 tests. The drawer front test, which simulates a pulling motion on a drawer, and the drawer bottom test, which simulates just a load in the drawer. These 2 tests are different from the casework in that casework is pass-fail. Drawer boxes are tested to failure. So every single drawer box that we test will fail at some point. We are taking that peak load that's applied to the drawer when it fails to determine its structural performance duty level. We have minimum thresholds for what duty levels 1, 2, 3, and 4 are. Generally speaking, every drawer box that we have tested has met a minimum of performance duty level 3, with a few rare exceptions. The couple things to keep in mind are the joinery involved in the drawer box and the type of material and the thickness of material play the biggest role. Drawer boxes that are made with 1/2-inch particle board or MDF do not perform as well as drawer boxes that are made with 3/4-inch particle board or MDF. Joinery can also play a big role in how a drawer box performs. And this is where I like to kind of ask the question of, and not to cheat and use an example that's already on the screen, but just real quickly in your mind, what is the strongest drawer box joint? That could be doweled, screwed, dovetailed. It could be stapled together. It could be some other type of joint. If you could just kind of drop in the chat quickly what you think the strongest drawer box joint is, because the next slide, I think we can have a little bit of fun with. So I'll give you just a second. See a lot of people saying dovetail. I see one with rabbit. I think the 2 people that said dovetail cheated and just said what they saw on the screen. But in all seriousness, every time, another one for dovetail, every time I give this presentation, dovetail is going to be the #1 answer that I get for strongest drawer box joint. What the next slide illustrates is a series of boxes that we have tested and their performance in our drawer front test. The numbers on the screen beneath the blue dots represent the load that was achieved at the point where the drawer box failed for the drawer front. What you see across the top row there is dowel screw, particle board, hardwood dowel, lock joint, miter fold, solid maple dovetail, and those specific dovetails are going to be veneer core plywood that are just dovetail, dowel screw in veneer core, hardwood dowel in veneer core, and lock joint. The interesting thing about this chart, and I think you can see my mouse cursor, is the 2 sections for dovetail are not necessarily the highest loads achieved. Some of the higher loads that we achieved were in veneer core plywood drawer boxes using dowel screws. And a dowel screw, I've been using the word conformat. Conformat and dowel screw are essentially interchangeable. They're a 7 millimeter diameter metal screw with very coarse threads. So this can beg the question of, why is dovetail not the strongest joint? And why would you continue to use dovetails if you are just after a stronger joint? And there's a couple of answers. One, if you look at the details of the solid maple dovetail and dovetail drawer boxes, you'll see that we tested those using 1/2 inch material and 5/8 inch material for solid wood. And for the veneer core, those were tested using 3/4 inch material. So it may not necessarily be that the joint itself is weaker, but it could be that the material starts to play a larger role in the point of failure. As I mentioned, 1/2 inch material, not quite as strong as 3/4 inch material. There is just less there to prevent flexing in that final breaking point. Veneer core plywood versus solid wood. Veneer core plywood is typically going to be at least 7 layers of veneer glued together with their bands alternating. If they're Baltic birch, then it could be an 11 or 13 layer Baltic birch plywood. So there's a lot of layers there with a lot of glue that add additional strength to the material. And in some cases, the strength of the joint can come down to those dowel screws. Like I said, they're 5 mm, 7 mm diameter metal rods that are screwed in. Those are not likely to bend or break under pressure, where even a wood dovetail is going to eventually fail because it's only as strong as the wood holding it together. And I already see the answer to the next question in the chat of why would you ever use dovetails? And the answer is aesthetics. Dovetails look very nice when you pull open a drawer and you see that joinery there. Not every project requires the aesthetics and cost of a dovetail drawer box. It could be a back of house storage. It could be like a point of sale drawer that the customer is never going to see. Maybe you just don't need the dovetail solid wood drawer box. So what this chart really illustrates in my mind is less so when you should use a certain joint, but rather most of the joinery used in drawer boxes is going to be somewhat created equal. It's really the material that the drawer box is made out of. So if you're wanting a stronger drawer box, you should specify a duty level 3 or 4 cabinet system, which would get you a duty level 3 or 4 drawer box. But understand that that is likely going to mean it's a 3/4 inch material, not necessarily a 1/2 inch material. If you specify a lower duty level, it could mean you just get a thinner material in that kind of 1/2 inch range. And then I see before automation in the chat, before automation, those would all have been cut by a very skilled craftsman, making drawers and nice antiques more valuable, not more sturdy, but more valuable. And yes, I agree with everything you said. Hand cut dovetails are done not for efficiency. They're done because of the aesthetic and value that is added to a piece. Today in production, dovetails are going to be cut by a machine, not necessarily hand cut. Again, whether or not it's hand cut or not, it adds to the aesthetic value of the cabinet, not necessarily the performance of the cabinet. But I think that to me is the biggest takeaway is don't over specify a dovetail because you're thinking it's going to be stronger. Specify a dovetail because you want the aesthetic value of a dovetail. And that's kind of what testing is showing us is it can be very easy to over specify because of these preconceived notions about what may or may not be the strongest versus what actually passes a performance test. So we have about 20 minutes left and a couple more slides to get through. So I might move a little bit more quickly. For some coming up, if you have questions or need me to slow down at all, please don't hesitate. But I just want to make sure we cover everything today. We also do testing on shelf suspension hardware. Our testing is specific to the type of shelf clip that is used. So whether it's a single pin spoonbill style, whether it's one of those L bracket styles, or whether it is an acrylic or nylon plastic pin, we're testing the performance in the specific core material that the cabinet is made out of. A shelf pin might perform slightly differently from particle board to MDF to veneer core plywood, just because of the characteristics of each of those materials. So our testing is specific to the combination of the shelf pin in the material. generally speaking, single pin style shelf clips perform less well than any dual pin shelf clip like that one kind of in the bottom, I'll call it middle right. Um, Single pins, regardless of whether they're metal or not compared to the plastic versions, perform less well because they're simply easier to leverage out of the side material. Dual pin systems perform very well because there are two pins holding it in place. They do not leverage out of the material as well. So they actually perform much better than any metal pin does, but their failure is much more dramatic, I'll say. The metal pin on the left will start to leverage itself out of the material. The shelf just kind of unceremoniously falls out. When the plastic pins reach their breaking point, for lack of a better word, they explode. The pins shear off the face of the plastic and the whole shelf drops out kind of dramatically. But to give you an idea of performance load values, a single pin spoonbill style, like the bottom left picture there, will typically fail at about 200 pounds loaded onto the shelf in our testing. Whereas the plastic style dual pin, depending on a couple factors, the type of shelf clip that's being used, whether it's made out of acrylic or nylon, whether it's in particle board MDF or veneer core plywood, will fail between 750 pounds of load on the shelf and about 1,100 pounds of load on the shelf. So it's not necessarily that plastic is better than metal. It's all the other factors that come into place of there's two pins holding it into place. They don't leverage and scoop out the material the same way that those single metal pins do. Again, there are aesthetic reasons you might want to use a particular shelf clip. Those little metal ones are essentially invisible. You can see that from the bottom of the shelf, but they're very minimalistic. They are very inexpensive, whereas those plastic pins, you can see in the shape of it. These hold a 3/4 inch shelf. The bottom of the shelf is going to rest on this ledge. The top 3/4 inch of that shelf is going to set right beneath this little plastic retaining clip there. So from the top of the shelf, you will see quite a bit of this plastic shelf clip exposed. From the bottom, it's a much larger, kind of chunkier piece of plastic that would be visible. But again, if performance is what you're after, then a duty level 4 shelf clip, which is the category that these tend to fall into. Sorry, I advanced the slide. The category that these fall into might be the most important. But if you're like, hey, I need a minimalistic look, I don't necessarily need that, then these metal shelf clips are, for all intents, fine. Just understand from a performance duty level standpoint, the way our standard is set up, these two are most likely going to fall into a duty level 1 or 2 category and be more likely to fail under a specific load. Is there a technical name for the plastic one with the retaining feature? To my knowledge, no, not a technical name. I tend to refer to them as dual pin shelf clips. If you are to Google dual pin shelf clips, you're going to get a variety of manufacturers. Bainbridge, Afala, Richelieu, Sugitsuni, all of the kind of big manufacturers for shelf clips are going to offer some variation of this. It might look a little bit different than this. As you can see on the screen, this one up here is a kind of rounded feature. The one in the bottom picture is squared off. Some are made out of a clear acrylic material. Others are an opaque nylon type material. Without getting into specifics, I'll just say they all have very similar performance characteristics once you get into that kind of dual pin feature that I described. Our standard also offers a formula for the adjustable shelf because thickness of the adjustable shelf plays a role in how much it will deflect under load. Our standard allows a 1/4 inch deflection. On the aesthetic side, anything greater than a 1/4 of an inch no longer conforms to our standard. This formula essentially determines the thickness of shelf that is allowable to meet that deflection requirement. It requires that you plug in a couple parameters. the load that's expected, the deflection, the MOE of the material, the thickness, and the span. And it will tell you at a certain width of cabinet whether the adjustable shelves need to be 3/4 of an inch, for example, or 1 inch, for example. So if the thickness of the shelf is critical in your design for one reason or another, maybe you're going for a minimalistic look where you don't want 1 inch adjustable shelves, this formula will tell you the maximum cabinet width that can have a 3/4 inch adjustable shelf. And yes, MOE, modulus of elasticity. It's in my kind of layman explanation of it, I'm sure somebody who knows much more could give you much more detail. It would be a metric of how stiff the material is. What is the maximum length of a shelf allowed to deflect 1/4 of an inch? That answer depends on a couple different parameters: the thickness of the shelf, and the MOE, or the stiffness of the material that's being used. So this chart on the screen is kind of a good example of that. This bottom row is MOE, from 400,000 going all the way up to 1.8 million. This kind of lower row here tells you whether it's a 3/4 inch shelf or a 1 inch shelf for each of those MOEs. So I'll just pick the example of 400,000 MOE, a 3/4 inch shelf. The maximum width of the cabinet would be 31 inches. At 1 inch thick on the adjustable shelf with a material of an MOE of 400,000, the maximum width of the cabinet is 39 inches. And those are based off of a 40-pound per square foot load. So as you can see, the thickness of the adjustable shelf actually impacts the width of the cabinet quite a bit. For the same MOE, we jumped from 31 inches to 39 inches for the maximum width. As you go up in MOE, meaning higher on the scale, all those values just kind of slowly increase. So how do you know if a manufacturer has gone through the whole testing process? Every manufacturer that goes through our testing process receives a test report. So if you aren't sure, then you would ask a manufacturer to show you their test report. If they cannot provide this document, then likely they have not gone through testing. This is going to be the conformance document that they receive that outlines exactly what they had tested, the materials that were used, the engineering drawings around the joinery methods that they used, essentially just a summary of everything they provided and what duty level that item met. And then kind of looking at the time to be aware, there's about 10 minutes left. I want to get into some of the aesthetic requirements. I know these are always scheduled, back to back with other meetings. If anyone does need to jump out early or stop right at the top of the hour, please don't hesitate to leave. Thank you for attending. I will try to get through the finish of this. So if you are able to kind of stick around maybe a couple minutes past, that would be great. But otherwise, no hard feelings if you do need to step out early. So I spent a lot of time covering the structural performance requirements of the new standard. And that is because that is the most different thing from previous standards to the Casework standard on the market today. We still cover all of the aesthetic requirements. We still cover premium, custom, and economy grade. And many of those requirements are unchanged. Some of them have been clarified. I don't necessarily have a great example. But I don't want anyone to go away from this and go, AWI is only worried about structural performance. That's not the case. Aesthetics are still the critical role in how an item gets specified and what the final product looks like. But the structural testing that we're doing is the biggest change from previous standards to today. So you can still expect to find all the things in there about what grade of veneer gets used, whether the interior of the cabinet needs to be melamine or HPDL, whether it's an exposed interior or a semi-exposed interior. It's still going to have all the requirements about what the gaps are allowed to be and what the tolerances of those gaps can be across the project. All of that information remains in the standard. I've said it a couple times now, it's still economy, custom, and premium. Economy is the lowest. Custom is middle of the ground and premium is the highest. We still have all these surface categories around cabinets and what applies to what. The outside of a cabinet is going to be an exposed exterior if it can be seen. If there are two cabinets side by side and you cannot see the side of a cabinet, then it's not exposed. It would be considered concealed. But this illustration kind of gives you a good idea of how we define the categories of a cabinet. And then the standard will determine what the material and what the requirements aesthetically for that material are based on these surface categories. And then kind of finally, why are specifications so important, especially on the aesthetic side? So up on the screen here, I have three pictures. I will say to some capacity, these pictures meet AWI standards. To others, they do not. Standards are important because they're going to dictate what is acceptable. And like I said at the beginning, offer everyone the same language to talk about the project. So kind of the three pictures here on the screen, what jumps out to you? What do you think would meet AWI standards? What do you think would not meet? The one on the left, a designer's worst nightmare. The one on the left is a designer's worst nightmare. To some extent, it's a manufacturer's worst nightmare as well. What is illustrated on the left is something referred to as barber polling, and that can be the topic of another presentation, really. But at the end of the day, that is a result of how wood veneer is cut and the match of wood veneer that it is laid up with. So on the left there, you see a book match in the wood veneer. When wood veneer is cut, one face of the veneer gets compressed and the other face gets kind of lifted up a little bit, just as a nature of how veneer is cut. When you book match it, you open it up like a book, so you're exposing a compressed face next to a lifted face side by side. Those two faces accept finish a little bit differently, which causes a light to reflect off of the faces, which gives you this barber pulling feature. The picture on the left, as much of a worst nightmare as it is, would technically be acceptable under AWI standards if the specifications called for book matching of veneer. That's just kind of what you can expect to see. It is a very extreme example of barber polling in book match veneer. The alignment between the top section and the bottom section would not be allowed. How there is a solid step between the two drawers that would pull out. The photo in the middle is something that is done to help alleviate barber pulling. This one is a swing match. So one piece of veneer is rotated 180 degrees from the piece of veneer next to it, but you're exposing that same compressed or lifted face across all the pieces of veneer, so there's not that striking difference. There are other methods you can do to alleviate barber pulling. One is to slip match veneer. The type of finish that gets used plays into all of this as well, whether it's stained or a natural finish. The species of wood can play a role in it. Some species are more prone to barber pulling than others. The right-hand image on the screen, I would say, is just a poor example of matching cabinets. There is no color or grain match between any of the components in the room. And I would just kind of say across the board, that is not likely to meet AWI standards. AWI standards, depending on the grade, requires that the color and grain be compatible or well matched between components in the room. Also a poor match in the wallpaper. Yeah, I'll just say it reminds me of my childhood. So specifications are important, and understanding the characteristics of wood veneer, solid wood, and what you're specifying can help alleviate the issues that you see on the screen. So specifications are important because at the end of the day, they control the product that you receive to some extent. The manufacturer also controls the product that you receive, but requiring that they meet a certain standard will help to alleviate a lot of issues. Only have a couple of minutes left, so I want to cover the quality certification program. AWI QCP is the quality assurance branch of AWI. They will license woodworkers, essentially saying we have licensed that this woodworker is capable and consistent in meeting AWI standards. They perform an inspection of any project that requires QCP. So they will come and inspect the installed product and provide you with a report of anything that does not meet the project specifications. That includes AWI standards. They are not just inspecting to AWI standards, they review the project specifications in their entirety. The cost is 0.5% of the millwork contract for items that require QCP. You could require QCP on just the casework, but not require QCP on other aspects of woodworking on the project. It is 0.5% of the portion of the contract that is required for QCP. There is a project minimum of $500 and a project maximum fee of $10,000. What you get, like I said, it's a third-party independent inspection to ensure everything that you specified is what you received at the end of the day on the project. Those can be written into the project contract, the project certification. Now, a manufacturer might go, yeah, the maximum project fee is $10,000. We meet that, but we put in a fee of $12,000 to cover QCP because there is additional paperwork, there is additional processing time in the facility. But what you should never really hear from a manufacturer is, I can save you $50,000 if you take QCP out. I want to be very transparent up front of AWI charges $500 minimum, $10,000 maximum, 0.5% of the millwork contract. The manufacturer has a little bit of flexibility in there to upcharge that a little bit because, like I said, it just takes them more time at the end of the day to manage a QCP project. And then last but not least, all AWI standards are available on our website, awinet.org, under the Standards tab. This is also a great resource for some education documents, membership information, standards, AWI community, and whatnot. And then for any information regarding AWI standards, to some extent QCP, please contact me. I'm available, I won't say 24/7, but if you send me an email, on a Thursday evening, very good chance, unless I'm out of the office, it gets replied to Friday morning. If it's a QCP specific question that I cannot answer, then I would just connect you with one of our QCP reps that could discuss that with you. If you want specifics, I'm happy to provide an email that can be distributed. Stacy, would I just give that to you?
Yes, that'd be great.
Okay. And then I can also distribute this slide deck as well. Stacy, I will email that to you.
Thank you. A couple other questions here then. Are there reps then to contact during the design process? I'm assuming we don't contact you with design questions or about the specs or drawings if we've got some questions along the way.
You can. We don't have a specific employee dedicated to assisting with design questions, but if something came up where you're working through a design and you have questions about what something might look like, I can offer some assistance. My background is from the woodworking industry. I spent 5 years doing engineering and drafting for various architectural woodwork firms, with experience from store fixtures to hospitality to casework, countertops, and wood wall paneling. And then QCP, while they might not get into the details of the design, pretty much anyone at AWI is willing and able to offer assistance as we can, or at least direct you to a resource more able to help.
That's great. Thank you. And then one other question that had been posted was regarding the performance standards. Are the spec writing platforms or programs acknowledging that portion yet of being able to spec which level?
Some are, some have not quite gotten there yet. We are working with several of the big players like RIB, which was formerly SpecLink, Deltek and MasterSpec, to make sure that what is present in their software represents accurately what AWI standards require. I would have to double check to see which has what available. I can't answer specifics just on the spot about it.
Okay. Well, many on the call right now obviously would be interested in that in particular, that as you evolve, you guys to help us we want to evolve with you. So thank you so much. This has been extremely helpful. If there's any other questions, you guys go ahead and pass them on to me, or feel free to reach out to Hunter yourself. And with that, I don't see any other open questions. So you guys enjoy your month. We will see you next month on, I should have been prepared for this. It will be February the 11th. And I believe the topic has to do with AI. So it'll be very interesting. So join us then. Hunter, thank you.
You're welcome. Thank you for having me. I appreciate the time.
Okay, bye everyone.